Okay. So one thing I wanted to do to kind of close out the bash lesson that we did, obviously we didn't get very far in this. It always happens that we never get very far in the, like all the way through the bash lesson. And right, like you get far enough to figure out some idea of like, okay, I can sort of see now why it might be useful to use a command line to navigate through my computer, to find stuff, to list stuff, right? A little bit further on, you see how to remove stuff. So you get a little bit more dangerous with your skills, but we never get far enough to show like what some of the actual practical uses of bash might be. And so real quick before we move on, I want to show you what one of them might be, one that is near and dear to my heart that I have done millions of times, right? And will continue to do millions of times is in my career, and might resonate with you all as well. So I'm going to go ahead and turn on the screen sharing. So for this, don't feel like you need to, just watch and follow along, right? That's the purpose of this, right? This is the kind of смотрите, пожалуйста, right? Like, let's watch the screen. And I'll make this as big as I can. Okay, so I'm back now at my home prompt. I've downloaded those shell lesson files again. I'm going to navigate to that directory where those data files are, right? So let's see where I am. They were in documents. So CD documents. They're in shell lesson data. And I know that within that folder, they're in the North Pacific Gyre folder. So I'm just going to go ahead and navigate all the way there with one CD command. And when I list the contents, right, it's just a bunch of text files mostly. And then these are what are called shell files, right? So this is a shell script. So this is kind of like the program that that our student Nell Nemo would have run on her data, right? This is her actual data file or her data files, right? So let's see, I want to see what's inside them, or one of them. I want to see what they look like. So I'm going to use a command that's called more, and I'm just going to select this first one and say, okay, I want to know what's in this file. So I'm going to paste the name of the file after more. Oh, more is not in there. Let's see, what might be is cats. Yeah, cat is there. So it's just a bunch of numbers, right? Like it's just a text file full of numbers, right? That may come from some device that's out in the field. This could be like, your infrasound array. This could be your soil moisture sensor. This could be your sap flux sensor, whatever, right? It's just a bunch of numbers, okay? And one of the very common things that we need to do, right? We talked about like, okay, one of the use cases is automating workflows, right? So presumably I might need to run some kind of analysis on all of these files, right? And an individual analysis might be open the file, read in the data, do some kind of math or whatever, write out some number or statistic to some other file or some data array, close the file, do it with the next file, right? And so often what I need is just a list of the file names in one file, right? Where I can read that one file in, and then I have all my file names, right? So I need a summary of the data files so that I can read that summary in and use that summary of the file names to start opening those data files, reading in the data, right? Then I can just loop through my files, right? So that's the hope, that's the goal. So we talked about flags. And so what I'm going to do is I'm going to use a flag I'm going to use the wildcard character, which was a little bit further down in the lesson on Bash. And I'm going to use something that is called a pipe, and I'll talk about, I'm going to show you how pipes, two different kinds of pipes, and how they are useful for these workflows. And you'll get a sense of like why and what are some circumstances under which you might use Bash to help with just some of your, it might be data management, it might be file kind of housekeeping, bookkeeping kind of things, right? To show you a couple use cases, okay? So the first thing that I'm going to do is I am going to do exactly what I mentioned might be a good use, which is to list the names of all of these text files, and I want to put them all in a single file, right? I want a text file of file names, right? Because when I create my code, whether it's in Python or R or MATLAB, I want all of the file names to be in one place so I could read in a file at a time, okay? So I'm going to do this in two steps, right? Well, I'll tell you how I'm going to manipulate the list command, the ls command, to give me the first part of my solution. And then I'm going to introduce this thing called a pipe to introduce the second part, right? So the first thing I want to do is I want to just say I want a list, and I want to use the flag -1. And what that switch is going to do is it's going to list everything in a single column, right? It's going to just list things as a column. Don't kind of do this. Don't try and fit it on one screen here. Just list it as a vertical list, right? Going straight down, one column. And then I also only want to list the text files because those are my data, right? In your case, it might be .dat files. It might be .netcdf, NC files, HDF files, right? But I just want the names of the text files. So I'm going to use use this wildcard character to invoke to list only my text files, okay? And I have to figure out, okay, this wildcard character, if I give it sort of a pattern, it's going to try and match all of the files that have that, all of the file names and folder names that have that pattern in it. Okay, so if I look at these file names here, nene0729a.txt all the way through 0204b.txt, what is one thing, right? What is a pattern in those file names that is shared across all of those text files, but only those text files?
Either everything with NEND or everything that is.
Yeah, so for the purposes of the recording, right, there's two ways we could do this. One thing that's in common is they all start with NENE, right, for Nell Nemo, our person that collected the data. So that's one way. They all also end in .txt, right? So that's another way. Either of those patterns are perfectly valid, right? There might be different reasons why we might use each one, right? There could be another file in here that's a .txt file. That's a very common extension that is not one of our data files, right? There could be an NENE file in here, similarly, that's the summary statistics of these data, right? That's the output of one of my analyses that I don't want to include it, right? So you have to think about what those patterns are, and sometimes pattern matching can be a real pain in the backside, and I could go off for hours on regular expressions and blah, blah, blah. I'm not going to do that, right? If you get really savvy in this, there's some really good tutorials. You can also just go bug when he's finally back for some period of time, Will Rudisil, who's really good with regex. But we need to kind of figure out how do we match these patterns, right? So I'm gonna show you both ways how I'm gonna do this. And I'm going to show you that both are perfectly valid for this particular circumstance. So I'm going to start with that first one, any. I want to match the files that have any. And so I'm going to say, okay, match any, and then whatever else, right? Star. Okay, I'm going to use the asterisk character, and that is my wildcard. And if you see what it did, right, it listed all of my files that started with any, and ended with a number.txt. Okay. Also perfectly equivalent, I could have used my asterisk.txt, and that also produced the same result. Also equivalent is I could have done NENE star.txt, right? And it returned the same thing, okay? So the wildcard is just a placeholder, right? It says match anything that's in between these, right? Or anything that you find that matches this pattern, right? This is a perfectly valid thing. I want to know the name of that file, okay? Okay, so that was step one. I've now been able to successfully just list the names of the files that I want. What I now want to do is I want to pipe the output of the list command to some file, right? It's spat it out to my screen, right? What in old school terminology is our so-called standard output, okay? I want it put in someplace a little more permanent, right? Someplace that I can refer back to. So what I'm going to do is I'm going to use the same command or one of the other three commands. I will use this dot. I'll zoom in even more. Actually, it's way at the bottom there. So I'm going to clear my screen. So I'm going to do ls -1 star.txt. And then I'm going to use the angle bracket, right? Or for those of you that fondly remember K-12 math, my Ally the alligator sign. No, they don't do that anymore. Yeah, they do. Okay. And I'm going to pipe it, and the arrow indicates the direction, right? I want to pipe it to something. And what I want to pipe it to is a file, right? And so I'm going to call this something generic. I'll call it something like data_files.txt. Okay, so when I pipe it, it didn't do anything. Okay, so if it didn't do anything and it didn't spit out an error or a warning, in Linux, that's often a good sign, right? So now if I type list, I have this file here called data_files. Okay. And I'm hoping that it has in it just the names of those text files, right? Just those text file names. So I'm going to use another command, cat, that you saw me use before. And I'm going to say cat data_files. And what this is just going to do is it's going to read the contents of this file to my standard output, to my screen. And if I am successful, if this was successful, what do I expect to see? Yep, the file names that we piped in, and they should be organized how? It should just be one column of file names, right? Okay. Lo and behold, that's exactly what we got, okay? So I now have, which is really cool, right, this data files.txt file that in, again, Python, MATLAB, R, IDL, whatever, I can just read this file name in. I can read all the file names into like a vector, right, or some kind of data structure that would allow me to loop through each file and do some kind of analysis, okay? Now, one complication is that if I now do a list again, and I want to list my files again using this .txt extension, I now have, right, another file that matches this, right? So I just have to be careful as I create new files, right? And the extensions that we use, okay? Okay, so that was use case number 1, okay? Use case number 2, I'm gonna see, perfect. And do we have said? Perfect, okay. All right, so the next use case is going to be that, it's just ls, okay? The next use case is that I have all of these files and I need to change the name somehow, right? So for whatever reason, they can't be named any some number. The number is fine, the any is the problem. Or the file name base is fine, but the extension is the problem, right? I have some program that requires my files to have an extension .dat, right? I have some program that requires all of my files to start with, you know, PCR, right? So what we're going to pretend here that we're going to shove these into a PCR machine to do batch, polymerase, chain reaction, biology, bioinformatics stuff, right? So I need to name these files. Instead of any, it has to be PCP 425 underscore, okay? For whatever weird reason. I'm not going to go and change the name of my program, or I'm not going to change the source code of my program to take any. It's some proprietary code that's in a .exe file. I'm just going to live with conformity and say, I will conform my file names to whatever this program requires, okay? Now, I could do this by changing the name, right? Or just like in my Windows or Finder, right? Like clicking on the name and typing a new name, right? That would be painful, okay? I could string together a series of commands using these pipes to accomplish the same thing, okay? And so that's what I'm going to opt to do instead. So the two commands that I'm going to use are fairly advanced commands, so don't worry about them. One's called awk, A-W-K. The other is called sed. They both stand for something. I honestly don't remember what they stand for. But what awk allows me to do, it allows me to decorate something with additional text. And what sed allows me to do is it allows me to change some sequence in a text string, right? Okay, so this is going to have 2, maybe 3 pipes, but it's going to let me change all of the names of these files in kind of one fell swoop, right? And this would work for, you know, however this is like 20 files, it would work for 20,000. Okay. Okay. So step 1 is largely the same as we did before. We want to be able to list which files start with any, and we want to just return that in a single column, right? So what was the command for that again? ls -1. Any star.txt or just any star, right? Okay. All right. So now what I want to do, okay, now what I want to do is I want to pipe this to another command. I want to pipe the output of this to something else that will allow me to start to build the command to change these names. Okay, and the command to change the names of these files each individually, if I was going to do this one file at a time, it would be move, MV, right? MV, move this file to its other name, right? It would be NE for this one, for instance, it would be it would be MV space NE 0729b.txt space PCR 245 underscore 07129b.txt. That would be the command to move one file. Okay. What I want to do is I want to construct a string of what that command would be for all of these files. Okay, and I'm going to use that command awk along with a pipe, a different kind of pipe to let me to do that. So we already saw how we could pipe the output of our list command to a file using that angle bracket. If I want to pipe it to another command, I can use the vertical bar, which is just shift and then the backslash button, right? It's the key that's right above the enter key on your keyboard. Okay. So that's a vertical pipe. So I can pipe this to another command. And the command I'm going to pipe this to is going to be awk. Okay. So again, don't worry about awk. It's a pretty complex command, but what I'm going to do is show you how I might do this, right? So this is going to be awk space, and we'll see how good I am at. We'll see, like, you'll see the pain of my PhD coming out here, like the old scars of this, right? So I believe this is quote curly brace print minus E. And I want to say double quote MV space quote $1 double quote space double quote $1 right curly brace single quote. Okay. Did I not? No, it's closed. I think I'm good. All right. Okay, so what is this going to do? Ooh, there's a 0 in it. I have no idea why there's a 0 in it. I don't know if that's a true 0. We'll see. Okay. Okay, so it added a 0. I have no idea why. We'll try and get rid of that if it's in fact true. I don't know if this is. Oh, well, whatever. Okay. So what did this do? What did awk do? Or what did I do here in general? So there's two commands here. This one here that you already know, right? We listed the output, or we listed the file names that started with NE. I then piped it to this command and I said, print a string. Print a string that consists of MV and then a space and then $1, which is just a shortcut for each one of these list command outputs, right? And then print another space, another white space, and then print the name of the file name again, right? Print #1 again, okay? Okay, so that gets me part of the way there, right? If I didn't run this, this is just a string. This doesn't do anything right now, okay? So if I were to run each of these commands, it would do something, but the net effect would be nothing, right? It would just change the name of the file from what it is to what it is, right? It would run that command and Linux would be fine with it, but you're just wasting energy and CPU cycles, okay? So now, what do we need? What would we need to do, right? If I can get this far, right? What might the next thing I want to do be, right? If I have the command here, I just need to tell it how to change this sequence, right? So if I can somehow use some other command to change this second occurrence of any to PCR 245 underscore, then I'm in pretty good shape, right? Okay. That's what we're gonna do. I'm going to pipe it to another command called sed. Let me see, it's actually the -e that is offensive to awk. Yep, that fixed it. Okay. All right. So now what I want to do is I want to pipe this to some other command that will give me the power to change any in all of these lines to something else. And that command is sed. Sed stands for string something. Okay, so sed. And sed has kind of a weird syntax. So again, this is not a command you necessarily need to worry about right now. Okay. Sed has this syntax where I'm going to say, okay, I want to substitute in my string. So I want to use s / and I want to use the pattern NE. So I want to match that pattern. And I want to change any to what? PCR 245 underscore. Okay. So that's the pattern I want to change it to. And on each line, which occurrence do I want to change? Do I want to change the first occurrence? Do I want to change the second? Do I want to change all occurrences? Yemi says just the second one. Is that right? So move from, move to, right? So this is the from file. I want to move from. I want to change the name from this. And this would be the to file, right? So I want to change the second occurrence. So I'm going to just type a 2 here. And I'm going to hit enter. Ooh la la. Right? Okay. That looks right. Right? Did I do it? Let's list. I didn't do it. Okay. But I can at least construct all of the arguments, right? I can at least construct each command to move those files. Now all I need to do is just tell Linux to actually just run these commands. Okay. How did we, and then what's the special thing that what's this thing called again that we use to chain together commands? What was it called? It's called a pipe, right? So wouldn't it be great if there was a way to just pipe this to like Linux and say, hey, I actually want you to do this, not just like write about it, right? Okay. Well, we can actually use a pipe again, and I can pipe it to this thing called sh, which is my shell, right? Which says, okay, push each one of these lines to the actual shell and run it. Okay. So when I do this, it paused for a second. Right? Did you see that? It kind of wasn't an instantaneous thing. But if I type ls -1 now, lo and behold, my file names are different. Okay. Okay. So there might have been other ways to do that. What was the advantage of going through all of these pipes? What did going through all these pipes allow me to do along and not just kind of changing the name by like really fast?
Kind of visualize where you're going.
That's right, right? Like if we scroll way back up here, right? Here's a good example. I said, this doesn't look right. I know that if I type 0mv at the prompt, I don't like Linux is gonna say, I don't know I don't know what you're telling me to do, right? So I was able to troubleshoot and I was able to kind of see, okay, like we need to make sure we have these commands right before I actually push it to the shell to run. Okay. So as much as these pipes look like a bunch of kind of, you know, gobbledygook kind of put together, the power of this is that it allows me to kind of manipulate thousands of files, up to thousands of files at once, but to do so in a way where I kind of can, like, you know, troubleshoot first and make sure that I am doing exactly what I'm trying to do, right? You should only push things to the shell when you're absolutely certain that that's what you want to do, because there's no going back. Okay. Yeah.
What is after the said? There's a S that begins. Is that just something with said that begins to look?
Yep. So great question. So this S in said stands for substitute, right? So when I use that, it means I want to substitute something in the out, right? So I've piped the output of awk, which is, right, which was this, right? So I piped this to the sed command, right? I piped it to the sed command and I said, substitute the second instance of any and change it to PCR245 underscore. Does that make sense? There's other things here. Honestly, substitute's the only one that I ever use, so I don't know what the other, I don't know what not substitute is. Okay. Other questions? Yes, yeah. So, okay, great question. So did I really change it for realsies? So let me go to my Windows Explorer and open and see all of these now are PCR245 underscore. Yes, that's the other question, is that if this was right, in this specific case, I have a zip file, right, of the original files with the any name, right, that I could unzip and just reuse again. But if this were the real world and this was and I had just changed the names, there would, well, I could go back, but it would just use the same commands, right? So if I wanted to do that, I could go back, but I would just switch things, right? I could just change things from PCR245 underscore to any, right? And you'll notice that I deleted the pipe to shell. So I just want to look at what this would do. Oh. Yeah, it would have to be, I have to change my list command. So list -1 PCR star would be fine. Okay. PCR. Thank you. PCR. Okay. So I could go the other way and move them back, right? Okay. But yeah, if I had deleted these, that's it. What's that?
If you close the bash, it's permanent.
Even if I don't close bash, it's permanent. Yeah. Was there another question?
Yeah, if you are working with thousands of files, you print out the name of thousands of files, you're going to have it with the files.
Yes, that's a great question. So the question is, if we are indeed working with thousands of files, it's hard for my eyes to see if it's right with thousands of files. And if it's tens of thousands of files, it would actually take forever to list, right? It would just keep dumping file names to the output. So is there a way to just display like the top several or the bottom or even interactively? So yes, there is. If I just do a ls -1 PCR star, right? If this was thousands of lines, right, it would be kind of a pain. There's a couple different ways I could do that. I could use a pipe again, right? I would use a pipe. I would pipe this to my favorite command, which is not installed here, is more, right? And more would just show me the top, and I could actually scroll down. And then when I was sufficiently confident that I did the right thing, or if I figured out that I did the wrong thing, I could just type Q, and that would quit out of more. So more is an interactive command. I could also pipe it to a command. I don't know if these are installed here. These would be installed on a full bash shell. I'll try piping it to tail, and that will show me the bottom of it, like the bottom X number. I don't know how many this is. This is maybe like 12 or whatever. You could also, can you pipe it to head? Yes, right. So I could look at the top number, but yeah, so and that pipe would also work with that full, right? So for this command, for instance, I could pipe, if this was thousands of files I was trying to if I was about to rename, right? I could similarly pipe this to tail or head or more, and it would only show me like the very bottom of them, right? Okay, that's a great question. Other questions? Yeah.
So before, what is seems like the observation that you get from the wild part.
Yep. Yeah, so that's exactly a good way of framing it. Awk is, I think it would describe, I don't remember what it stands for. It would describe itself as a word processor, right? So it lets you process input to it. So any string you input to awk, you can do all sorts of things with it, right? You can substitute text. I could have done this in like with just awk, but I'm actually like, I only use awk for very basic things because it's very complicated. But yeah, awk lets you process any string input. Okay. Yes, the two means the second instance, right? So what this will do, right? So let me see if I can. So if I wanted to replace the I don't remember the command and said. So I can tell said, for instance, to replace the first instance, the second instance, the third instance, if there was one, as many arbitrarily. There's also a way to tell said to replace all of them, right? I just don't remember off the top of my head what the letter or character is to tell it to do that. Any other questions?
So if you use like a space. Oh.
Great question. So if I missed a space, right? So this is like, you have to be very careful, right? So if I missed this space, let's show you here, right? So if I missed this, oops, if I missed that space, okay, it would, right? It would just, like that white space wouldn't be included. If I pipe this to shell, so this is a good thing to think about, right? If I pipe this command to shell, what would happen? It wouldn't work. Why? It's what? Yeah, so there's two reasons it wouldn't work. It would fail, right? The first reason is that every move command has to have a from and a to. Because that white space is no longer in here, there's no to, right? Okay, if there is a file named this nonsense, right? You're not telling me what to move it to, okay? Second, there's no file that has this name, all this nonsense, right? So you're gonna get either one of those failures, right? Either this file doesn't exist or error with a usage statement saying, hey, read move and how to move the stuff.
Does every command have like a help associated with it? So if you said that help to see if we want to choose relevant?
Yeah, so that's a great question. So that is always, and that came up in that bash lesson from Tuesday. -- help is always a really good guess for what the help command is, right? So if I type sed minus help, I will get, in fact, the help statement, right? So this is actually the short version of sed. There's also a secret, an old school way of getting a more detailed depiction of how sed works is I could use what's called man for manual, right? And the manual pages have to be installed. They may not be installed here, so this may not work, but I can try to type man space sed. And yeah, the manual pages are not installed here, but manual gives you a much more detailed, like TMI version of how to use the command. TMI for too much information, sorry. Any other questions? So a last comment on bash before we pivot to using git. I mean, we're going to be using git in the context of bash, but I am by no means a power user of Linux, right? There are people both in this, well, in my research group, and people in this building that are far more competent bash users. But what I would say about this is that those skills are perishable, right? So I forget how to use awk frequently. I forget how to use sed, right? I forget some flags every now and again. But you kind of just have to remember the basics, right? Like, so things like pipes, like the vertical pipe, right? The equivalent to that is like remembering that in Spanish and is E, right? Why, right? Like you can always tack something on if you know what and is, right? So there's things like, okay, I may not exactly remember the 100% version of how to use awk. I can Google that, but I do know I can pipe it together with something else with a vertical bar. Okay. So just as you go through, right, don't feel like you need to always remember these things. If you're not already a savvy Google user, you will be at the end of this class because I do a lot of Googling, right? My friends that teach programming all joke that like our classes are just where we teach you really good Google skills, right? And also that, there's a couple reasons for teaching bash, right? One is so that you get a little bit closer to like the lower levels of the machine so you can manipulate things. The other is so you see that like, you can experiment with things and you're not going to break the computer. Okay. Linux by design, and this is actually true, by design, and you saw that a little bit with those hidden files that started with dot, right? Linux is meant to be like, to mess something up, you have to be doing it intentionally, right? That's how Linux was built, okay? Windows was not, and it created some really interesting things in the 90s. But Linux is built such that if you want to mess something up, you really have to be trying. Okay, so experimentation, Google, iteration, those things are all good and valuable. Okay. Okay. So we're going to pivot to Git now, version control with Git. We will not get through the whole lesson today. Some background. So go ahead and open. I want to make this bigger. Oh. There, no. Okay, here we go. All right, so if you haven't already, there's no files that are required there's no files required for this tutorial. We're going to make all of the files that we need. But what I will have you do is go ahead, if you haven't already, this should only take about 5 minutes for you to read. And so go ahead and take the time to read this. And when you get down to key points here, if you have your flags, put your flags up. Otherwise, I don't know, I'll just be looking for you. So, okay. I forgot to bring the sticky notes. I told myself I wouldn't, and then the next day I forgot them, so. Okay. How many of you are PhD comic fans? Just a few of you? Oh, wow. Okay. It's like, let's see what the PhD comic is for today. So this was today's. They have a really great one on climate change. I'll try and find it and send it. It's a very nerdy. Let's see what the previous academic Wordle datum graph paper right stuck cries. It's great. Right, this was a PhD comic from a long time ago. It's been in the Git software carpentry lesson forever, right? And even if you're not at the end of your graduate studies, this perhaps resonates with you, right? This idea that, right, you think you're finished with something and then you're actually not finished with it, right? And we go back and we just append things, right? Many of your advisors do this. Some are extra bad at this because, right, this becomes to be a problematic practice, right? Today is September 1st, right? So a very common thing that will happen is that I send out a manuscript or an abstract file for revision and review by some colleagues. They send it back and they append a name on it, right? And it's you know, so it's like the base version of your name, like AGU underscore abstract, and then they append like underscore LF Lejo Flores 090122, right? Somebody else appends underscore JPM, Jim McNamara, stepped 01, right? And they all wind up in the same folder. How do I know what's the latest version, right? And do they reconcile with one another, right? Did Jim make edits on top of mine, or did we both make edits in parallel? And should it matter, right? Shouldn't we be able to make edits in parallel and then figure out a way to reconcile them in a more automated way, rather than having to have our poor graduate students look at 2 Word docs side by side and be like, oh, they both edited the same sentence, but in very different ways. What do I do? Right. So that's exactly what version control is. And truthfully, you can use version control for Word docs. Some people have used version control for Word docs. Most often, though, we use it for our code, right? And it is this idea that, you know, we have people that are adding lines, that are subtracting lines, that are inserting lines, and we need some way to make sure that we both don't lose those changes, but also that we can document the order in which they're done, right? So we know, like, okay, somebody added this line, but then somebody promptly deleted it and inserted something else. And maybe that's okay, because, right, maybe somebody saw, oh, I see what this person is trying to do, and that's a really good idea, but there's a slightly better way of doing it, right? Or they may not know about this one command that allows you to do this in a much more efficient amount of time or much more economical amount of code. Okay, so that's exactly what version control is for. You will hear it's increasingly common that Git is sort of the universal version control piece of software that people use, but it is not the only version control software, right? When I was a grad student at the time, people were still using this thing called Subversion, right? Or Subversion, depending on if you're subversive or not. CVS was another common one, not the store that gives you mile-long receipts, but this, I don't remember what CVS stands for, control version system or something. And then there's another one that was more recent, but is sort of faded in popularity, called Mercurial. One thing that's important to know is that often we will use the words Git and GitHub interchangeably. And that's actually like, that's not the greatest practice, because they're different things, right? GitHub is a web server where we can store our GitHub repositories that provides us an API, a way of pushing our repositories to the cloud and pulling them back down and managing some of our changes. Okay, but there are other ways to do it, right? You can run your own version control server using GitLab, right? That's actually what the USGS does. So the USGS has its own kind of GitHub instance, right? So this is code.usgs.gov. They're running a version of GitLab, right? Which allows them to host their own Git repositories in their own way, right? And there's probably public records and kind of federal policy that governs why the USGS can't necessarily use GitHub for everything and anything, right? Private companies will have their own GitLab instances. There's also other private companies that offer similar solutions. So some of you may have heard of Bitbucket, right? So Bitbucket is another way of using Git. It's by a company called Atlassian. Atlassian not only has Bitbucket, which is like a version of GitHub, they have a whole bunch of other kind of project management software, right? So since code is often a project, they have this solution because this allows you to kind of interact with it and say, hey, we need to make progress on this one part of this code. And you can assign it as a ticket to one of your software developers in your company or something, right? So it's important for us to kind of know that Git and GitHub are different, right? Git is the software that allows us to do version control. GitHub is the place where we are most frequently storing our software, okay? Okay, so let's go ahead and get started. And a good place, how many of you have already created your GitHub accounts? Okay, awesome, great. Okay, so go ahead and open either a terminal or a Git for Windows bash terminal. I think the other thing that you can do is maybe open, where did it go? There is this Git CMD. Oh, that's different. So keep using Git bash. Okay. And so the first thing that we do on any computer, if this is, because this is the like shared university computer, this will not persist. But anytime you use Git on your own computer, the first thing that you need to do is set up who is using Git, right? Who is it on your computer that's using Git? And the way to do that is using these Git config commands, right? So the first thing that we're going to do is tell Git on our computer who we are. Now, the important thing is that whatever email you set here in this configuration command is the same email that is tied to your GitHub account if you want to use Git from the command line, which you hopefully do, right? So I'm going to start by typing git config -- global space user dot name, and I will put, I guess I should put Alejandro Flores. You can type whatever you want, right? So this is important because this name here is what will appear on your what are called git commits later, right? That's how your name will appear. Okay, so that's step one. And again, right, as with most bash commands, if I don't receive any kind of feedback, right, if there's nothing, nothing there, right, there's no warning, there's no error when I typed in that command, it means that it ran fine. Okay. Okay. So the next thing to do is to add my email address. So git config -- global user dot email, and this is Alejo Flores at boisestate.edu.
Already have to get, is there a way that you can see all this? Shoot, we've done it before.
Yes, there is. So this is where I'm going to show you like the way how I'm not like, I don't know this off the top of my head. I'm just going to say display git config. List and show git config settings. Okay, so this is an important side note for the rest of the semester and potentially the rest of your programming lives if you don't know it. So as I Google these things, my filter, my mental filter looks first for, right, whatever the top hit is. But the one that I'm looking for is a solution to an answer on Stack Overflow, right? So Stack Overflow is this kind of forum where people who are coders go to ask questions and get answers, okay? And why do I choose Stack Overflow? The answer is that when people post to Stack Overflow, okay, so you'll see this question. I'd like to show all git configured sections. I only found git config -- git core.editor. I'd like to output everything that's configured globally, not only the configured default editor. Okay, so this sounds close enough to my question in that if I can display all of the global settings, among them are the name and the email address, that if this was successfully answered, this solution is good enough for me, right? So I'm going to scroll down, and here is an answer, and it says you can use git config -- list, or look at your ~/.git config file. The local configuration will be in your blah, 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 blah. Use git config, whatever. Okay. All right. So there's a lot there, but I want you to note one thing here. Okay. And that's this green check, right? So this green check means that whoever asked this question, whoever posted this, tried what this person suggested, and it worked. And so they came back to Stack Overflow and said, yes, this worked for me. Okay. So this is a little bit of a way of like verifying, right? Like if only Twitter had a kind of like, hey, this was, you know, the correct post, right? And not just like some crazy, you know, like our social media would be a lot better if people could sort of say this was the right answer, right? Okay, so I'm going to just try this command. I'm going to say, okay, git config -- list. Okay, so there's a lot of things here, but if I check this one down here, this is in fact what my username or my name and my email are. Okay. there's a lot of other things here that I don't really care about at the moment. But here's here's the answer to your question, Scott. So that was a side loop that we got off on sort of navigating the web and where I can find answers that are helpful, right? But it's an important one. I use Stack Overflow all the time. Okay. Let's see. So there's some notes here on, making sure that you are secure with your email. There's some things that we're going to have to get into in terms of how we interact with GitHub, the website. Some of that has changed in recent years to get more secure. We now use what are called SSH keys to verify and authenticate that we are the person we say we are when we're pushing stuff onto a GitHub repository. It adds a couple of levels of complexity relative to where it was like a year ago, but it's actually a lot safer. And when you get it dialed in, is a lot easier now. Okay. So, all right. For this tutorial, we need some kind of text editor, and you're going to be saving files in a folder. Okay, you're going to be saving files in a folder, and you need to be able to like edit. Those are just going to be text files for now. So how many of you do not know whether or not you have access to a text editor? And mind you, by the way, that if you are on Git for Windows, Git for Windows does have the so-called Nano text editor, which is a really easy to use text editor. And this lesson actually has some prompts and how to, it actually supposes you're using the Nano text editor. Okay. Let's do this. Let's actually go ahead and read this, and then we'll call it a day for our Git demo. When we come back on Tuesday, we will go through the creating a repository, tracking changes, and exploring history. We'll do ignoring things too. So we're going to go through 3, 4, 5, and 6 on Tuesday. But just for now, go ahead and finish reading Set Up Git, and when you're done, you can just head out. Okay. Nano. Hit Control and then X. Did that work? Yeah, so what you did was what's called a hard exit. So anything you would have entered into the text editor would have been lost. You would have had to do something to like save it if you wanted to.